And this is a skill video for PME, find reaction force for a beam. We're going to look in two cases. One is for a point load, and the other case is if you have a distributed load. So in the case of a point load, what we need to do is we need to apply two conditions, first of which is to do with our forces. The resultant force on our beam is 0 if it's in equilibrium. So we will do that. First off, let's make sure our diagram includes the whole picture. There are going to be reaction forces supporting the weight of the beam applied at A and applied from B. Then we're going to make sure that we look at the forces that are acting. The total force acting on an object in equilibrium is 0. So our total resultant force is 0. Finding our resultant force here, the easy way, is look at the forces that are acting upwards. That is the reaction at A plus the reaction at B. Take away the forces that are acting downwards. Take away 20 equals 0. So we see that reaction A plus reaction B is equal to 20 newtons. Now, that is not enough to solve our problem, but it helps. Then we need to apply our second condition for beams, which is that the total moment at any point is 0 if it's in equilibrium. So we can take moments about A or B, or we could take moments about the centre. We're going to take moments at one of these because what it does is it makes it so we can find, makes it so that the moment caused by one of the reaction forces is 0 because it goes straight through the pivot and lets us find the other. So let's take, for example, the reaction at B. So take moments about B. So the sum of moments about B is equal to 0. Then we need to just find our moments. We do this by considering the anti-clockwise moments, take away the clockwise moments, equal to 0. The anti-clockwise moment here is going to be caused by this 20 newtons, and if it's a moment, it is the force times the distance, so that's 20 newtons times 6. Take away. Now our clockwise moment is going to be the reaction at A times its lever arm. Now here we can see it is 6 meters plus 6 meters, which is 12 meters. We know they're both equal to 0. So we simplify and rearrange this. 20 times 6 is 120. And then we're going to add 12 lots of RA to both sides. 12 RA is going to be equal to 120. And that lets us find our reaction force at A. It's going to just be simply 120 divided by 12, which is 10 newtons. We are nearly there. We've found one of our reaction forces. We then go back to this equation we wrote before, and we find the other. So RA plus RB equal to 20. Now RA we found to be 10 plus RB is equal to 20. So reaction at B is going to be equal to 20 less 10, which is 10 newtons. Then for uniformly distributed loads, we have to take a slightly different route. There is an extra step involved. We can't calculate this uniformly distributed load of 5 newtons per metre, which means for each metre on here, of which there are 12, there is 5 newtons pressing down on that metre. There's 12 in total, so we could replace this, and in fact we shall replace this with a second diagram with, well, we replace our uniformly distributed load with a point load of equivalent size acting in the centre. So here, what is the total force on this beam? Well, each metre has got 5 newtons on it, and there is 12 metres. 5 times 12 is 60 newtons. So we can see that our point load, equivalent point load, will be 60 newtons, acting in the middle of our 2 supports. That bit is important. It's always in between the 2 supports. Then we solve it the same as before. Total force equals 0. We've got the reaction at A, got the reaction force at B. So RA plus RB minus our load is going to be equal to 0. So that tells us that RA plus RB is going to be equal to 60. Then we go through our moments. We can take moments about either side. Let's take about A, living dangerously. So moments about A. Looking here, we've got, if we put our pivots here, at A, we've got a 60 Newton acting at 6 metres, which would be our clockwise moment, so that'd be negative. And then our anti-clockwise moment is going to be reaction B acting at 6 plus 6. So 12 into reaction B is equal to that. 12 RB is going to be equal to 360. So our reaction force B is going to be equal to 30 newtons. Then we find reaction force at A. We know that both added together is 60. 60 take away 30 is 30. And we are done.